Hello everyone and welcome to the channel. I'm Emanuel. I'm currently in the Airbus A330 type rating, and in this video I want to show you 5 ways how to start an engine in an Airbus aircraft. The first one you're all well familiar with, that is the standard engine start. We've got the APU, we've got APU bleed, so all we gotta do, flick that beacon light on, put the engine into ignition start, flick on the engine start switch, and voila, it is starting up. Now that is the very easy way, and that is the way that you're all familiar with. So let's quickly reverse these and make things a little bit more interesting. So let's say that today we had to do a manual engine start, which is going to be way number 2, how to start an Airbus engine. So manual starting is recommended in case of an aborted engine start from the auto start because of engine stall, engine EGT overlimit, or low start air pressure. When expecting a start abort because of degraded bleed performance due to hot conditions or at high altitude airfields, an engine with a reduced EGT margin in hot conditions or at a high altitude airfield, marginal performance of an external pneumatic power group, or intermittent ECAM engine ignition fault alert during the first start of the day, it is also recommended to do a manual engine start. So let's have a look into the manual engine start procedure. It is actually quite easy. So thrust levers go to idle, engine mode selector, normal, then ignition. This is important because if you previously attempted an automatic engine start and the start failed, then the ECAM will prompt you to return the engine starter into the off position, and then the engine start selector is going to remain in ignition start. And when that happens, after 30 seconds the packs come on again, and therefore you will not have sufficient bleed air available anymore for engine start. For that reason, first step in the procedure is to go normal and then back to ignition start, which basically resets the start logic. So you're gonna wait until all parameters are shown on the engine warning display or the upper ECAM display, and when that happens we do the following. Manual start push button on, those are located on the overhead panel over here. Start valve check in line, that's the one down here. N2 increase check, oil pressure increase check, and if the N2 does not reach 20%, we do the following. Then we check for the pack valves to be closed, and if APU bleed is used for engine start and the pack valves are closed, we can set the APU electrical load as follows. Galleon cabin push button off, so that one's located up on the overhead down here, galleon cap off, and if needed we can also set the blue electric hydraulic pump. We can put the fuel crossfeed on and turn fuel pump except the right tank pump number 2 off. We can put the blower to override and the cabin fans off. So that is really how to get the most performance out of your manual engine start. When the N2 reaches 22% or the maximum motoring speed, minimum of 20%, we put the engine master on and start the chrono, and the PM starts timing in order to monitor the light up duration. We check igniters A and B are on and fuel flow increases, and 15 seconds maximum after fuel flow increase we verify the EGT increases and N1 increases. When N2 reaches 50%, start valve check crossline, igniters A and B check off manual, main engine parameters check normal, secondary engine parameters check normal. Then we turn the engine manual start push button switch to off and the engine mode selector back to normal. When no other engine requires to be started manually, shattered systems restore, SOP for engine start resume. Alright, so let's see what that looks like in practical terms. Now for today's condition, we will probably get a normal start even without the need to shed all those systems, but nonetheless I just want to show you what it looks like in case we do it. Okay then, let's go ahead with the manual engine start. Thrust lever idle, engine mode selector, normal, then ignition start. Okay, our parameters are all showing in green. So, engine manual start push button on. We'll start engine number 2, on. Start valve, check in line, N2 increases, oil pressure increases. So, when N2 reaches 22%, which is the case now, engine master number 2, on, chrono, start. And now within 15 seconds we need EGT light up, and you can see we already have that. Okay then, next up, when N2 reaches 50%, which is going to be the case very shortly, here we go. The start valve is crossed, igniters A and B off, main engine parameters, check normal, secondary engine parameters, check normal, engine manual start push button off, and engine mode selector normal. Okay, and that is all there is to the manual engine start. Now let's quickly reload, and I see you again on way to start the AIRBUS engine number 2. And up to the next one. Engine start with an air start unit. So, before we connect the air start unit, we got to make sure the packs are off to prevent any possible contamination of the packs by the air start unit. When the unit is connected and we are clear to start, we are going to start engine number 2 first, but for any operational reasons required, engine 1 can be started first. In this case, check the brake accu pressure prior to engine start, as we will have insufficient, or rather as we will not have the hydraulic system supply the brake system. However, as you can see, we've got sufficient air pressure available, or rather sufficient brake pressure available, so let's go ahead with our engine start. Okay, before connecting the air start unit, pack 1 and 2 off. So that's both packs off. Then, APU bleed off, engine 1 bleed off, engine 2 bleed off, and cross bleed open. Okay, next up we're going to request connection of the air start unit, and we can get one down here in the menu, maintenance, ground services, and ground air. So that is on. Okay, when clear to start, engine 2 start. So, engine start selector ignition, we've got sufficient pressure available down here, and then we can go ahead. We need minimum 30 psi when the start valve is open. So let's start engine number 2. Okay, start valve opens, we've got 36 psi, so we are within the 30 required, and now the engine start commences. And as we can see, we get a pretty much normal engine start with this. Alright, so after starting engine number 2 with an air start unit, we need to decide if we want to start the other engine as well, or if we are going to disconnect the air starter at that point and do a cross-bleed start later. This is actually the recommended procedure because it means there will be less of a hazard for the ground personnel and therefore less danger associated with the procedures. So that is what we're going to do. Okay, after engine 2 is started, we are going to deselect the external power, like here, off, and then request external power disconnection. There is a warning there. Disconnecting the external power with the external power push button set to on may cause injury to the ground engineer. Request disconnection of the external power only when the external power push button is set to avail. Okay, so that's the case now, and now we can go ahead and disconnect external power and external air, like so. Okay, we don't need all of those ECAMs, we can ignore them for now. And since the cross-bleed engine start procedure will be used to start engine number 1, we can go ahead and turn some of our air conditioning back on. So in our case, we're going to do pack 1 on, pack 2 on, engine 2 bleed on, and now we can go ahead with the cross-bleed engine start procedure. And this concludes our air start, so let's go ahead with procedure number 4, how to start an AIRBUS engine, and this is going to be the cross-bleed engine start procedure. Caution: do not perform the cross-bleed engine start procedure during a pushback. Simultaneous use of engine bleed supply and external pneumatic power is prohibited. So, especially when you came previously from the engine start with an air start unit procedure, you want to be sure that the ground power and the ground air are disconnected. Okay, one engine must be running in order to supply air for the other engine start. Before the second engine start, APU bleed off, the bleed valve of the supplying engine reopens and the cross bleed valve closes. So, engine bleed on the supplying engine on, that's engine number 2, and that's turn on. Engine bleed on the receiving engine off. The receiving is going to be engine number 1, the one that we want to start, and that is off. The bleed valve of the receiving engine is closed to avoid reverse flow leakage. Okay, cross bleed open, and it is still open from our previous start procedure. When clear to start, area clear of obstacles, confirm. Ensure increased power jet weight does not constitute any hazard to people or installations behind the aircraft. Thrust lever on the supplying engine adjust for bleed pressure. So adjust thrust of supplying engine to obtain an engine bleed pressure of 30 psi before start initiation and at least 25 psi during the start sequence. If the thrust required to obtain the appropriate engine bleed pressure exceeds 40% N1, pay particular attention to the surrounding area. And from here on, we are simply going to use normal start procedures. Okay, so let's check on our Ecam. We've got 24 psi at the moment, and we said that we are looking for 30 psi before the start initiation and 25 during the start sequence. So let's go ahead and increase thrust on the number 2 engine. You can see the pressure is slowly increasing. Okay, that's 30 psi. I do like to get a tiny bit more though, so let's use the 40% that we're allowed to use, because the pressure is going to drop once we initiate engine start. Okay, that's 40% N1, 30 psi. Okay, so start engine number 1. Okay, now the pressure has dropped to 24 psi, so let's increase thrust a tiny bit more, just to be sure that we actually get sufficient pressure. This would have to be coordinated now with the ground guys, since we are using more than 40% N1. It is permissible, but you have to be careful. As you can see, we just need a tiny bit more, so that is totally acceptable for us. And engine number 1 is starting. Okay, here we go, start valve is closed. So, after start, thrust lever on the supplying engine to idle. Cross bleed, auto. Auto. Engine bleed on the receiving engine on. That's going to be engine number 1. On. Pack 1 on. Pack 2 on. And that is the cross bleed engine start procedure completed. Alright, that is 4 ways how to start an Airbus engine. There is a 5th. Unfortunately, I'm not able to show you that within the simulator because simply no add-on that I'm aware of actually offers that option. And that option is an engine start valve manual operation. So if you had an engine start valve fall, then the start valve can be operated manually by the ground engineers. Now, for this you will typically need an actual engineer and not just a ramp agent or your typical ground crew. So if this happens, well. Okay, so let's quickly discuss the engine start valve manual operation procedure. And with both engines shut down, you would basically aim for a more or less normal engine start. However, there's a couple differences. First of all, the engineer is going to plug himself in, not at the typical interphone position that you would use to talk to the normal ground crew, but at the headphone jack at the engine. And that means he's going to be on the cabin interphone, so all the cabin crew can hear what you're going to say. So before you start the procedure, it is a good idea to tell the cabin crew just to stop talking for a couple moments as you need their interphone. From here on, you obtain ground crew clearance, and it doesn't matter which source of bleed air you use. So it can be either the standard procedure with air supplied by the APU or with the ground air unit and so on. there are several different possibilities. Then what's going to happen is as follows. You tell the ground crew that you want to start the engine mode select, ignition start, engine master on. And once the engine master has been selected to on, you are going to tell the ground engineer open start valve and keep open. And the start valve is built in a way that it automatically closes if you don't keep it open. So this means the ground engineer has to continuously apply pressure on his tools in order to actually keep the valve open. When N2 reaches 50% N1, you're going to tell the engineer close start valve and then resume standard SOP, and that is your engine started. So that's 5 ways how to start an Airbus engine. I do hope you found this one interesting. If you did, do let me know in the comments below. I'm looking forward to read what you think about this, and as always, if you liked the video, be sure to leave a like, comment to let me know what you think about it, and finally, if you are looking for more, subscribe to the channel. If you really love what I'm doing, I would appreciate a small donation through the Buy Me Coffee link in the video description below, and in the meantime, I'd like to say thank you very much for watching, hope you enjoyed this one, and I'm looking forward to see you all again on the next one.